Hello, I'm Julian Crawford,
And I'm Jaden Chow.
and this is our final integrated circuit design for analog and digital circuits 2E03. Now, the objective of this project is to make a 7-segment display cycle through one of our student numbers. Now, the number we chose is my student number, 400, 504, 160. And now we'll see that our 7-segment display, 504, 160. And it does, in fact, display through it.
Now we'll move on to the multisim to display how our analytical solution based off K-maps produce an accurate multisim that loops through this exact same student number. Seen in the top right is each digit of the student number, and seen in the top left is the counter showing the iteration through the student number itself.
So 5, 0, 4, 1, 6, and then 0.
And to build this circuit, we use a combination of different flip-flop gates, OR gates, and AND gates. As seen in the top left of our circuit, we have an OR gate, followed by an AND gate, followed by our second OR gate. And at the bottom of our circuit, we have 3 IC chips made of 6 flip-flops, and our decoder on the right.
Now, to optimize this, to use as few ICs as possible, we had to choose whether we wanted to use a SOP or POS implementation to use as few IC chips as possible. Now, for most of these, we use an SOP implementation to get away with using a couple OR gates, but for some of the JK flip-flops, we had to use a POS implementation to get around using NAND gates or not AND gates.
Whichever solution was the most efficient is what we used to reduce the amount of logic gates required.
Yep, and keep in mind our student number, and none of the digits go above 7, so we could get away with using only 5 flip-flops instead of the 6 you'd normally have to use.
Now for the actual construction of our circuit, I was able to color code and highlight our actual multisim as seen by these wires, with the dark blue representing our clears and our resets. Then scrolling up, I took screenshots of all the IC chips, the OR gates, and the AND gates used in our circuit in its exact order, and then connected it by wires color-coded related to the multisim itself.
Now, looking at our wires, it seems disorganized, it seems super tangled, but in actuality, this is more so because a consequence of the fact that our multisim has a lot of wires that go over top of each other and double back on each other quite a lot.
So again, to help us organize this very complex spaghetti bowl of wires, we color-coded and connected each leg of this IC chips to its designated inputs and outputs.
Yep, so all in all, this functions. And we'll show that we're using 5-volt input with a current of under 150 amps, 150 milliamps.
With 0.9 hertz used as our clock.
Yeah, 0.9 hertz as our clock to make it reasonably paced. We don't want it moving too fast. And the tolerance of current on the 7-segment display is around 150 milliamps. So we used a 22 ohm resistor to ground it so that our amperage isn't too high.